Okay, in this lesson, we are going to be looking specifically at some certain kinds of sequences. The first one we're going to look at is arithmetic sequences. Those are ones where you continue to either add or subtract, which is really like adding a negative, um, the same number to each sequence. Here's what you need to know. This formula right here is the recursive formula for arithmetic sequences. So we can't find the next term until we know the term before it, okay? There is also an explicit formula, which I know will look familiar to you, and it goes like this, okay? You probably want to write that in your notes because I don't think I got it copied in there. Maybe I did. But this is your explicit formula for arithmetic sequences, okay? So what we are going to do is we are going to, first of all, look at this arithmetic sequence. And I can tell it's arithmetic by looking at whether I'm adding or subtracting the same thing each time. To get from -2 to 1, I add 3. To get from 1 to 4, I add 3. Okay, so part A asks me to find my common difference. And that's exactly what my common difference is to add 3. If I was subtracting 3, I would say my common difference is -3. Okay, but it's not. I am adding it. The next thing it asks me to do is to find the 10th term, which I will actually do in a minute. And first of all, I'm going to do part C next, which is asking me to find a recursive formula. Here is your recursive formula right here. You're not going to plug any numbers in. All you need to do is say that AN equals AN minus 1 plus your common difference, which is 3. Okay, so this is the recursive formula. And I will do part D next, which is explicit. Okay, if you look at your notes in that box that you have, the explicit formula goes like this. AN is A1, which is the first term, plus n minus 1 times d. So in this case, the first term is -2. I'm not going to plug anything in for n because I want this formula to be able to be used for any term number. And then my common difference is 3. And I'm going to make this just a little bit prettier by distributing that 3 through. So then I have -2 plus 3n minus 3. And I'll make it even prettier by combining my like terms and getting it to 3n minus 5. So I'm going to box these off. This is recursive. This is my explicit formula. Okay, and I'm going to go back to part B, which is asking me to find my 10th term. Easiest to find your 10th term from the explicit formula. So I am going to use the explicit formula that I just created. And to find the 10th term, I'm just going to go 3 times 10 minus 5, or 30 minus 5, which is 25. So 8, 10 is 25. Okay, now I am fully aware that some of you might find the 10th term by just adding 3 and making this be 10 and then 13 and 16 and da, da, da. Certainly that works, but you need to know how to do it algebraically as well so that if I ask you to find the 99th term, you're not sitting and writing 99 terms out. That would be really frustrating. So you need to know how to do it algebraically as well. Okay. Then, of course, we're going to look at a geometric sequence. And down here is the recursive formula for a geometric sequence. So this is recursive. Okay, and let me give you the explicit formula so that you can add to that in case you don't have it. So the explicit formula goes like this. AN is A1 times R, which is your common ratio, to the n minus 1 power. So make sure you write that down so that you have that as well. All right, here's a geometric one. Okay. Here, to get from 2 to -6, I would multiply by -3. Okay. if you don't know what you're multiplying by, you can figure it out in this case by doing 18 divided by negative 6 gives me negative 3. Or negative 6 divided by 2 gives me negative 3. Okay? Sometimes you have to do that. Sometimes when you do that, you're actually dividing by something. So actually, if my sequence went the other way around and it went 18, negative 6, 2, da 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 da, then my ratio would be negative 1/3. Okay? Don't say that your ratio is 3 because you're dividing by negative 3. Okay? It's negative 1/3 because you're multiplying. It's always what you're multiplying by. And multiplying is the same as dividing by the reciprocal. Okay? Anyways, in this case, my common ratio is negative 3. Oops, not rational, ratio. Okay. Again, I am going to do part C next. Part C asks me to write a recursive formula. The recursive formula is the one that you see right here. All you have to do is plug in the R for it. So my AN would be AN minus 1 times R, which in this case would be negative 3. Probably could make that be a little bit prettier and make it be negative 3 times A to the N minus 1. That would make that be a little bit prettier. This is the recursive. Okay, then I will do part D next. Part D is asking me to find an explicit formula. Okay, the explicit formula goes AN equals A1 times R to the N minus 1. So if I plug in what I need to there, I would have AN equals 2 times negative 3 to the N minus 1. Some people want to simplify that and make that be negative 6 to the N minus 1. You can't do that because you have to do your exponents first, and you don't have a number that you're plugging in for N right now. So don't simplify this to make this be negative 6. This is your explicit. Okay, and then I am going to go back and do part B, and part B is asking me to find the 10th term. Okay, easiest to do that if you have an explicit formula. So to find the 10th term, I'm going to take 2 times negative 3 to the 10 minus 1, which of course is 2 times negative 3 to the 9th power. Make sure if you're going to stick this into your calculator that you put it in a way that your calculator will follow the order of operations. Because you have a negative here, super duper duper important that you have that negative 3 in parentheses. So make sure you do that. So type it in probably just like you see it so that your calculator will get those order of operations correct. Okay. And when you do that, I think you get negative 39,366. Okay. And then we're going to do one more, and this is asking us to say the third and the sixth terms of a sequence are 48 and 6 respectively. Find the explicit and recursive formulas if it's a geometric or an arithmetic sequence. Okay, so here we go. First of all, let's start out. I'm going to just drag these up here because they're bugging me. Okay. I am first of all going to start out with it being arithmetic. Okay, here's what I want you to think about. If it's arithmetic, so I have 1, 2, 3, 4, 5, 6 terms. Okay, the third term is 48, and the sixth term is 6. Okay, if it's arithmetic, I am adding or subtracting to get to the next number every single time. Clearly, I can see I'm going to subtract in this case because I'm going from a bigger number, which is 48, to a smaller number, which is 6. Here's the deal. You have 1, 2, 3 differences. You're going from 48 to 6, so do 6 minus 48, the second number minus, and I get negative 42. And that has to be split amongst 3 differences, which makes my common difference be negative 14. Okay, my common difference is negative 14. So I can get this next number by subtracting 14 if I want to, and I could get 34, subtract 14, and I get 20. If I go the other way, I have to add 14, okay? So 48 plus 14 would be 62, and 62 plus 14 would be 76, okay? That's one way you can do that. Excuse me. So now, if I want to write a recursive formula, this is your recursive formula right here for an arithmetic sequence. I'll just put that next to it. And all I need to do is plug in the numbers that I have. Okay, so my recursive formula would be an equals an minus 1 plus my constant difference, which is actually negative 14. Okay, my explicit formula then, remember, goes an equals a1 plus n minus 1 times d. So in this case, my first term is 76. I'm not going to plug anything in for n. My common difference is negative 14. Okay, then I want you to distribute that negative 14 through and simplify all that, which I know you can handle, and I will tell you you get negative 14n plus 90. Okay, this is an explicit formula. All right, then let's do geometric. If this were geometric, and it kind of followed the same pattern, this was a 48 and this was a 6, okay, I need to think about how I am going to divide these three ratios. Okay, so here's what I want you to think about. This is 6. I always take the farther number first. 6 divided by 48, and when I divide that by 48, I get 1/8. That 1/8 has to happen in 1, 2, 3 ratios. So this is like saying it's r to the third power. Okay, so you need to think about what do you take to the third power to get 1/8. So this will be 1/2 to the third power. Okay, hopefully you can figure out that you're dividing by 2, dividing by 2, dividing by 2. And so if you want to fill in some numbers here, you can. Half of 48 is 24, half of 24 is 12, half of 12 is 6. If I go the other way around, I have 96 and 192. Okay, so here we go. Let's do recursive. So recursive is an equals an minus 1 times r. So in this case, that would be an minus 1 times 1/2. And again, you're probably going to make that be a little bit prettier and put that in front like that so that it looks like that. Okay, and then lastly, let's do explicit for that. And your explicit formula goes a1 times r to the n minus 1, which in this case, my first term was 192. My r was 1/2 to the n minus 1. Okay, and that's what that should look like, and that is that lesson.